What is an emulsion? An emulsion is a mixture of two or more immiscible liquids, for instance, oil and water. These liquids are described as immiscible because they cannot be easily mixed together and will readily separate. You can temporarily cause the oil and water to mix by adding energy and shaking it. This is now an emulsion, but this will quickly separate. However, if you add some carefully chosen emulsifiers or surfactants and mix correctly, you can create a mixture that will be more stable and will not readily separate. A stable emulsion has three basic components. One is the continuous or external phase. This is the phase in which everything else is suspended. The second component is the dispersed phase, or the internal phase. This is the component that you are suspending in the continuous phase. Finally, the third component is the emulsifier, or surfactant. This creates a layer around the dispersed phase and separates it from the continuous phase. Both the continuous and dispersed phase can have other additives for specific needs. There are several varieties of emulsions. Oil and water, where the oil is the dispersed phase and water is the continuous phase. Water and oil emulsions, where the water is the dispersed phase and oil is the continuous phase. And multiple emulsions, such as a water and oil and water emulsion. This video will only focus on oil and water emulsions. What is a surfactant? A surfactant is an amphiphilic molecule, meaning it has both a hydrophilic head group and a hydrophobic tail group. These surfactants accumulate at the interface of the oil and water, with the hydrophilic head sitting in the water and the hydrophobic tail sitting in the oil. This increases the barrier of energy that prevents the dispersion from separating and going back to the lowest energy state. Dow carries a wide variety of surfactants to help you with your emulsification needs. An important point to remember is that emulsions are thermodynamically unstable and want to return to their lowest energy state, which is as two separate liquids. The speed of how quickly an emulsion will separate can be described using Stokes' law. The two important factors that can be changed to slow down particle movement are the radius of the dispersed phase droplets or the viscosity of the continuous phase. You can increase the viscosity by adding various thickeners. It is important to understand under what conditions various thickeners will disperse to minimize clumping. Dow offers a variety of thickeners. The other variable you can manipulate is the particle size of the droplets. Droplet size can be in the nanometers up to hundreds of microns. Droplet size will not only affect the stability of the emulsion, but other properties such as effectiveness in the application, color, and viscosity. Particle size is typically expressed as dV50, meaning that 50% of particles by volume are below that particle size. Similarly, 90% of the distribution is below the dV90, and 10% of the distribution is below the dV10. Emulsions with dV50 below 100 nanometers will be transparent to semi-transparent. Emulsions from 100 nanometers to approximately 300 nanometers will be opaque with a blue tint. Above 1 micron will be opaque in shades of white. Particle size distribution is also important, as a stable emulsion will generally have a narrow distribution without any extraneous peaks. The particle size and distribution you target will also depend on the application. For instance, in anti-foam emulsions, you want a dV50 between 10 and 20 microns, and a dV90 below 100 microns. If the particle size is too large, the emulsion will be unstable, and if it is too low, it will not be an effective antifoam. You can target your particle size by using the correct shear device. For emulsions with a large particle size, you may be able to make an emulsion just using the agitator in your vessel. As you work down to smaller particle sizes, you may need specialized shear devices such as rotor-stator shear devices or high-pressure shear devices. Finally, there are other additives that can also improve performance. Adding a biocide or other preservative to your formulation can help to protect against microbial growth. Microbes can utilize surfactants and other additives as food and can destabilize your product. You may also need to adjust the pH or add a pH buffer to make the biocide work effectively. Whatever your need is, Dow has the solution. If you have more questions, reach out to our customer service representatives.